Hello dear students, welcome you all. Well, in this lecture, I am going to take up the question number 5 of the section C of your question paper. The question number 4 I have already discussed in the previous lecture. Now I am going to the question number 5 and it is section C. Right? It is from section C. In question number 5, we have two parts. The first part is derive the differential equation of the orbit in a central force field, and then the B part is the path of the particle moving under the action of a force is given by r is equal to a cos theta. Calculate the corresponding force law. Right? This is a numerical problem. First of all, we have to derive the differential equation of the orbit in central force field. Now again, this question is from the topic gravitational force and inverse square law of force. So for that, we have to recall the equation. I am solving question number 5 part A, right? So it is question number 5A, right? So to solve this question, first of all, we have to recall the equation of the motion of a body under central force field, right? This was the article, and in that article we have derived the expression for the equation of motion under central force field by taking into consideration plane polar coordinate system. And when we solved the equation, we found two equations. The first one is mu r square, mu r double dash minus mu r theta dash square, right, is equal to fr. So this is the first equation that we call as a radial equation, and we have one more equation there, mu r theta double dash plus 2 mu r dash theta dash is equal to 0, right? This equation we call as a theta coordinate equation, right? And this is the radial part of the equation. We have two equations in the solution of that problem that I am saying you that the equation of the motion in central force field, that equation of motion contain two parts, one associated with the er radial part and one associated with the e theta, right? That is the angle part, or we can say theta coordinate part, right? Because in plane polar coordinate system we have one radial distance and one we have a angle from the fixed axis. These are the two coordinates. So now I'm in deriving the differential equation, I am making the use of this equation number 1 only, radial part, right? So once again I am writing this equation. The equation is mu r double dash minus mu r theta dash square is equal to the force fr, force under which this entire process is taking place, and this force is a central force field. Mu is the reduced mass, r is the position vector, r and theta is the angle theta, right, in plane polar coordinate system, right? Now I can write, let this is equation number 2, right? I can write this equation, r double dash minus r theta dash square is equal to f r upon mu, right? This is equation number 3, right? Now let's recall the value of angular momentum in plane polar coordinate system. We know very well that angular momentum L in plane polar coordinate system, L is equal to mu r square theta dash. This is the expression that we have found when we were dealing in this chapter in the beginning, angular momentum and energy of the body when it is moving under the influence of central force field. This was the expression for L. So from here, theta dash is equal to L upon mu r square, right? So this is the value. So I am going to put this value here. So when I put this value, I got double dash minus r into theta dash square means L square upon mu square into r power 4. So I got r power 3 is equal to f into r upon mu. So I got from here r double dash minus L square upon mu square into R cube is equal to 1 upon mu into FR. This is the equation that I got after putting this value here. Now, let's take a substitution. R is equal to 1 upon U, not mu, remember, 1 upon U. Now I change this position coordinate R into a new coordinate U, right? So that will be the R dash. R dash means dr upon dt. It will become 1 upon u square minus du upon dt. Simply, this is the differentiation. R dash. So R dash minus 1 upon u square du upon dt. I can write it as R dash is equal to minus 1 upon u square du upon d theta into d theta upon dt. So d theta upon dt simply becomes theta dash, right? Theta dot we can say. So it becomes minus 1 upon u square theta dash du upon d theta. Remember, once again I am saying that this is mu, and this is a u, right? So you have to keep in mind that this is u and u is equal to 1 upon r, right? So this is what? This is r dash, right? Now what is the r double dash? R double dash obviously means dr dash upon dt. So it will become d upon dt into minus 1 upon u square theta dash du upon d theta, right? This is what it becomes. Now I can further simplify it again in the same way, that I will write it as d upon d theta into minus 1 upon u square theta dash du upon d theta into d theta upon dt, right? So d theta upon dt, again it becomes theta dash, right? So r double dash becomes equal to d upon d theta into minus 1 upon u square theta dash into du upon d theta into theta dash, right? So this is what I got from here. Now I am going to put the value of this r double dash. This is r double dash, let it is equation number 4. So I am going to put the equation number 4 in equation number 3, right? Because here we have a r double dash value, right? I will also put the value of theta dash square and the value of r also, right? So this equation, in that scenario, when I will replace all these values, this equation is going to become r double dash. R double dash means d upon d theta bracket minus 1 upon u square theta dash du upon d theta into theta dash, right? Minus, what was there? You can see r theta dash square. R means 1 upon u theta dash square. So theta dash square L square upon this one mu square r power 4 into L square upon mu square r power 4. R means, let's write it as r power 4. So this one is this one, and on the right hand side I have 1 upon mu fr. So it becomes is equal to 1 upon mu into fr means 1 upon u now, right? Now here r is 1 upon u, so it becomes r power 4 means it becomes 1 upon u power 4 into 1 upon u power 4. So u square, right? So u square, when you will take this square upward, you will get it u power. What it was, I think, L square upon, let me check it. So I have mistaken here. So I even got confused or mistaken in u and mu. So it was actually mu. So it cannot cancel out with this one. So it will remain as it is. It will cancel out and I will get u power 3. So u power 3 will go to there. And in the denominator, I will get mu square as it is, right? So what I got after simplification, so you have to keep in mind that u square and mu square, right? U is different thing, mu is different thing. So what I got here minus L square, I am writing on this term only, into mu square into u cube, right? It will go in the denominator, is equal to 1 upon mu f of 1 upon u, right? So this is what I got from here. Now I know what is the value of theta dash, right? So I'm going to put the value of theta dash here in these two places. So theta dash was, you can see here, L upon mu r square, right? So it becomes now d upon d theta minus 1 upon u square theta dash. Theta dash is L upon mu r square. L upon mu into r square means u square, 1 upon u square, so 1 upon u square into du upon d theta into again theta dash L u square upon mu, because theta dash is equal to L upon mu r square. So I put this values here. So minus, same thing, L square u cube upon mu power mu square, right? That is equal to 1 upon mu f of 1 upon mu, not mu, 1 upon u, right? So you can cancel out the things which are getting cancelled. So here you can see in this equation u square cancelled. You got minus L u square, right? Minus L, this is u square and it becomes L square divided by mu square into d square. Now it becomes d square u upon d theta square, right? Minus L square u power 3 divided by mu square is equal to 1 upon mu into f 1 upon u, right? So I got this equation. I can further simplify it by taking it this side, mu toward this side. So when I will take it here, what I will get? I will get, I can simply multiply by mu on both the sides. So in that case, I will get minus L square u square upon mu, let me correct it, mu, right, into d square u upon d theta square, right, plus, not plus, minus L square u cube upon, now here it will become, when I multiplied by mu on both the sides, it will, I will left with only mu only, and here I forgot to multiply, but no, I have multiplied. Okay, so then in this side I am left with f 1 upon u. right? So this is what I got here. So I can further simplify this equation by multiplying on both the side by negative. This one positive, positive, it becomes negative. I am also taking this term as the common, and I am multiplying on both the sides with the mu upon L square u square. So here I will get, and I multiply it, d square u upon d theta square plus, and I multiply it here, L square cancelled, mu cancelled, I get u only, is equal to minus mu upon L square u square f of 1 upon u. This is the equation number 5. This is the required differential equation. That was the answer to this question, and that was asked in the question. Differential equation of the orbit in central force field, and this equation is in terms of plane polar coordinates r and theta, right? So this is the answer. You can derive this equation right up to this point, and you have to memorize or remember this equation, because this equation is going to be used in solving the numerical problem, which I am also going to solve as the part B of this question number 5, right? Derive the differential equation we have derived. Now the path of the particle moving under the action of force is given by r is equal to a cos theta. Calculate the corresponding force law. So to solve this type of questions, these type of questions are usually asked. 3 to 4 questions are given in your book. You can go to that and solve these questions. So for solving these questions, we have to make the use of this differential equation. So the first and foremost thing is that we have to remember the differential equation. So now question number 5A is over. B. I'm going to question number B now, right? So this is question number 5, part B. Right. You are given the path of the particle moving under the influence of a force R is equal to A cos theta. You are asked to find the force law. I mean FR, proportionality in terms of R. How it is, whether it is proportional to R square, inversely proportional to R square, inversely proportional to R cube. So we have to take the help of this equation, right? Now as we are given R is equal to A cos theta, so this equation is basically in U, and we know U is equal to 1 upon R. So if I put the value of R here, so I got U is equal to A upon 1 upon A cos theta. So it becomes secant theta upon A, right? So this is U. Now what I need? I need d square U upon d theta square. So for that, first of all, du upon d theta. So du upon theta, I am differentiating this. A is constant. Secant theta differentiation is a secant theta and tan theta divided by A. This is the differentiation, right? Now what is d square U upon d theta square? So d square U upon d theta square means d theta of du upon d theta, and that means d upon d theta of secant theta tan theta upon A, right? So we have to simplify this differentiation. So I can simplify it by using the product rule of the differentiation. So 1 upon A, as it is constant, bracket secant theta into tan theta means secant square theta. So it becomes, let it is taking secant square theta, then plus secant theta into tan square theta, because the differentiation of secant theta is secant theta tan theta. I think I call it wrongly in the first part. We took secant theta as it is, and the differentiation of tan theta was secant square theta. Then it becomes secant cube theta. In the second part, I took the tan theta as it is, and the differentiation of secant theta is secant theta tan theta. So it becomes secant theta tan square theta, right? So it becomes, in the next step, secant cube theta plus secant theta tan square theta divided by into 1 upon a, right? So this is what? This is d square u upon d theta square. So now I have the value of d square u upon d theta square. I have the value of u. I am going to put these all values in equation number 5, right? This equation. We have to put this value here. So what I will get? D square u upon d theta square means secant cube theta plus secant theta tan square theta upon a plus u means secant theta upon a is equal to minus mu upon L square. What is there? It was yes, minus mu upon L square u square. U square means 1 upon a square cos square theta. So into u square is here, u square. So u square means 1 upon let's say a square cos square theta. So it will become, when you put the value of u square here, when you put the value of u square, it becomes u square means into 1 upon a square cos square theta, right, into f of r, right? So what I got from here? I got from here left hand side, I can take 1 upon a as common, right? So I got secant cube theta plus secant theta common tan square theta plus 1, right, divided by no divided by, because we have already taken it common, right, is equal to minus mu into a square divided by L square. 1 upon cos square theta means secant square theta into f r, right? F r I am writing because there is 1 upon u, so 1 upon u is r, right? Now let's 1 plus tan square theta is what? It is secant square theta. So I got secant cube theta plus secant cube theta divided by a, right, is equal to minus a square mu upon L square secant square theta f of r, right? So when you will simplify it, it becomes 2 secant cube theta, 2 secant cube theta divided by a is equal to minus a square mu upon L square secant square theta, right, into f upon r, right? So now I am taking the term toward this side, fr. I am taking fr this side. So fr is equal to, when this is taken to here, it will become 2 secant cube theta, right, upon a into L square secant square theta divided by minus a square mu. So secant, it becomes minus 2 L square secant power 5 theta into a square, no, it becomes it was a cube, it becomes it is a cube, yes, 2 L square secant power theta divided by, I was wrong, divided by 1 power cube mu, right? So this is what I got from here. So now I can write it, Fr is equal to minus 2 L square A square. Now what is secant theta? You see here, secant theta, yes, secant theta is equal to A into u, right? As u is equal to a cos theta, secant theta, so secant theta is equal to a into u, right? So let's put the value of secant theta here. It becomes into a u, because secant theta is this, secant theta is equal to a u. So secant power 5, a power 5 into u power 5, right, divided by what I have, a cube mu, right? So a cube a square, right, a power cancelled, so u power 5, right? So I got here a cube, yes, I got minus 2 L square A square, because here it is power 3, so I think I mistaken here, let me check it, minus 2 L square, yes, I have used A square here, minus 2 L square secant power 5 means A power 5 U power 5, right? So A square was not there, I think I mistaken here, it was a minus 2 L square secant power 5 theta, so A power 5 U power 5, so A power 2 left here into U power 5 divided by mu, right? So now U is what? U is 1 upon R. So Fr is equal to minus 2 L square A square, right, into mu into R power 5. U power 5 means 1 upon R power 5. So as all these terms L, A and mu, they are constant, right? R is only variable. So Fr, we can say it is directly proportional to, and it is negative, 1 upon R power 5. So we can say that this force is inversely proportional to the fifth power of R, and it is attractive because it is negative. So this was the answer to this question. So you can see here we started from this equation. First of all, we have to remember this equation, derivation of this equation. Then by R is equal to a cos theta, we took 1 upon R, that is u, d square du upon d theta, then d square u upon d theta, put all these values in this equation, then simplified, and finally got the answer Fr is equal to 1 upon R power, directly proportional to 1 upon R power 5, right? So this is the answer to this question number B of question number 5, section C. So now section C is complete. Now in the next lecture, I will go to the section D of this question paper, right? So thank you very much.